timer. Thanks.
Cool. So can everyone see my PowerPoint presentation okay? Hopefully. Yeah, so security best practices for Azure DevOps pipeline. I'm Sean Allen, an integration developer from TrustPower. A little bit about me. Here we go. So I'm based in Tauranga, New Zealand. I've got about 3 years of IT experience, all in software development. A mulesoft certified developer in Mule 4. Areas of expertise is pipelines, CI/CD, automation, scripting, full stack, mainly backend API development, but also got expertise or a little bit of knowledge in React, not really Angular or anything else. And fun fact about myself is I like Muay Thai. I'm a Muay Thai enthusiast, and I generally do that most afternoons. So we'll just get into the agenda next. So we've got some technical challenges or business objectives, DevSecOps, CI/CD, pipeline security, demo, pipeline improvements, and then some key takeaways. So we'll just get stuck into it and ask questions in the chat as I go, and I think Joy or Arcana will point them out as I go. So some of the technical challenges we had is we wanted a way to externalize our application properties, but also be able to lock this down to certain users, so only mulesoft developers, for example. Secure updates with PRs to a central repo. If our environment mule key ever gets compromised for any reason, we wanted an easy and dynamic way to update applications. We did not want to hard code secrets, so TCOPs can't see secrets if they wanted to adjust things inside the pipeline. Mule key to be dynamic, so you can't hard code secrets if you want a dynamic mule key. Removal of secrets from the properties file means less risk of accidental exposure. And we also, it's just good practice, right? So this is where our Azure Key Vault came in, was for externalizing those. And our DevOps permissions for service connections was a little bit of a challenge of how we were going to access our Key Vault to get our secrets. So a little bit about DevSecOps is just how can we secure the CI/CD pipelines, remove all secrets from files, and securely retrieve them when we need to. What is DevSecOps? It's practice of integrating security practices into the DevOps process. It means that DevOps security is automated. Every pipeline we set up needs permission to access ARM template repositories, access our pipeline templates, access secrets, removal of hard-coded plain text or encrypted secrets. And we had to find a way to securely access and retrieve those secrets and be careful not to expose them in doing so. Which leads me to our next slide. So set up a new application pipeline. This is one of our first pipelines that is sort of hit by any of our Mule applications. So this is basically how we onboard a new application. The pipeline handles all permissions a new application will need. It's the ability, or adds the ability to be able to access template files, service connections, and key vaults. Handles all scaffolding, so to set up the properties file and application settings file, which I'll get to later on. And it also creates the application pipeline inside of our target repository. So that's basically the full setup. Slide. So service hooks with logic apps is how we trigger our automation onboarding. So the previous slide that I just spoke about. So when a project is first created, we must manually run a logic app to set up the service hooks, but that's only for each project. So once a project has service hooks set up for it, we don't have to run that logic app anymore. So how do we automate our application onboarding? It is just by that, service hooks, logic apps. Service hooks are kind of like events. We can trigger it based off of Git commits, PR created, PRs completed. If it's a Git commit, it will have for example, certain properties and fields being sent through inside of the webhook. So it's basically just like a post webhook. We can see the project ID, repository ID, branch references. We can kind of interrogate the payload to extract any information we need out. We can validate the event or hook for the required project. So in this particular case, for a MuleSoft project, does the project name start with MuleSoft dash, which is one of our recommendations, is that all projects start with MuleSoft dash process, MuleSoft dash system, or MuleSoft dash experience, and then followed by a domain. We can set up a list of projects inside the Logic app to exclude, for example, our MuleSoft pipelines project, which I'll kind of show you guys a little bit later on. And also we can check if the branch is one that we're allowed to modify. So most of our projects and repositories have branches, master and developer kind of our default, and we've got policies set up against them, so we can't chuck code straight in there. It has to go through a PR or code review process. When a MuleSoft repository has an application file added to it, how do we stop the automation from triggering itself again? This is where we kind of just use make sure the application pipeline file that we've added to it is the same as what exists there currently. And that's what we use to stop that automation from basically getting stuck in a loop and just reoccurring. Excuse me. So if developers also modify the pipeline file, this will check to set it back to what it should be. So building an application using centralized property files based on environment variables. We want to test the environment configuration file matches what the application is expecting. So because we've got external properties, we want to make sure that they match the application the way it pulls through the secrets or the global configurations. Because of the way our Mule APIs are set up, the properties file must be in the same path. So that path we can kind of see in the first bullet point where file equals properties mule.environment-properties.yaml. So when we run things locally, our Mule environment is just set to local. And then when we build or deploy, we set the Mule environment to our Cloud Hub environment or the one that we're targeting. So dev for development, QA for QA, production for production, for example. Want to check the environment file will compile and build for current application version, so any changes that have been made. And only fails in the build step if the app has in-unit tests set up. Otherwise, the app will be deployed and fail to start in Cloud Hub. That's kind of a key point to take away from this slide, is that we found that we could build an application and it would compile fine, but when we were running it inside of Cloud Hub, that's when the issues would arise. So just one way to stop that from happening was to make sure all applications have in-unit tests set up for them, especially before they go into production. And the PowerShell build task, the reason why we use that over a native Maven task was just because the Maven task was exposing the mule key to the console, which you could see in plain text, and that's extremely bad, so we didn't want to do that. POM configuration validation. So we do some basic validation of project POM files. This is to make sure all of our projects are following the Trustpower standard. If the project has munit, for example, we want to force a certain percentage. In Trustpower's case, we want to force our 75% test case coverage. And all projects want to have the same group ID and make sure that the artifact ID matches their repository name. We want to make sure that artifact ID matches the repo name because the repo name is basically used for everything inside of our design center. When we publish into Exchange, I think that's the ID it's given. And then when we set up our pipeline, the pipeline name is also the repository name. So everything kind of relates and matches the whole way through our process. So the main reason why I wanted to discuss munit a little bit more was just to let everyone know about the build will compile but not run if the environment properties file doesn't match what the properties the application needs to run is. So if we have an incorrect environment property file with no immunit test. The build will succeed and be deployed, but it won't be able to start and run in Cloud Hub. So we'll get a deploy error, and then we get a whole bunch of nasty messages come through on Slack saying that it's failed to start. And it's also good practice just to have testing in the CI pipeline. So definitely a good to have there. So trigger an app pipeline based on branch name. Pipeline triggers is what we use to run the application in a CI/CD fashion. Using this, we can trigger a build for all target branches, and if the requirements are met, it will also trigger the CD phase of the pipeline. For the trigger to kick in, we just need to modify a branch. So a commit to a feature branch, for example, will trigger the pipeline. A PR into master will trigger the pipeline, and we can also manually trigger the pipeline for a target branch, whichever one we select. Excuse me. The keynote here is that not all branches will trigger continuous deployment. So we do use other checks and groups for this, which leads me into our next slide. Deploying an application based on branch name. So our pipeline has been triggered, but how do we know what environment to deploy to? This is where we use pipeline conditions. These allow us to inspect which branch the pipeline has been triggered for, and we map our branches to our Cloud Hub environments inside of our conditions in our deploy file. Without the mappings, we don't really know which branch we want to deploy to. So it's probably the key takeaway here for pipeline conditions is that we use them to map them between our Cloud Hub environment and our Azure DevOps version control branches. The Anypoint CLI is what we use to deploy our applications. We basically use the Anypoint CLI for a whole range of different reasons. One of them is for the working out which command to use when we want to deploy an application. So if any of you guys have used Anypoint CLI before to deploy applications, if they already exist, we have to change the command from a deploy to a modify. If they're there and not running, I believe we have to start them. And to be able to check if they're there, we use the application list command, which is very handy to have that there when we need to change the command. We do some API calls, but generally that's just to switch on custom logging, implement SLA tiers, which I'll speak more to later. A couple of issues we ran into was, like I just said, where the command needs to change, and the fix for that was using the application list. We've also got the application deploy or modify command was returning a result of a previously deployed application. So what I mean by that is if we've deployed an application and that was in an error state, and then we deploy another one that's running successfully, the CLI command was returning the error state from the previous application, even though the new application was deployed and running successfully. So when I got in contact with MuleSoft, one of the ways around that was to use the application describe command, which we haven't implemented yet. That is on our list of features to extend our pipeline, make it a little bit more better, and also so we can set up our rollbacks as well. Once we get that working properly, I can re-enable our rollbacks that we've got set up, and that would work fine. So like I mentioned before, we've got certain checks and group memberships and stuff in place for whether or not a branch can deploy into a Cloud Hub environment. Auto deploy is used for CD to our sandbox environments mainly, so development and QA. It can be used for production, but should be considered bad because anyone that or thing, for example, a PR completed, will trigger the pipeline for, say, master, and then regardless of what set or the permissions that the person has, will trigger the pipeline and it will do a deploy, which is quite bad. And here at TrustPower, we have change requests around all of our production deployments. So if we haven't scheduled a change, we don't want to release the new application into production. especially because we've got a Slack channel that people keep an eye on, and you can see when a new application has been deployed. Group membership is kind of what we use to override the auto deploy flag, mainly used for deploying into production, and it's also a way of restricting who can deploy into our production environment. For example, we've only got about 4 or 5 devs, I believe, which are members of the group. So there's only about 4 or 5 of us that can release MuleSoft applications into production. And everyone in the group should be aware that anytime they manually trigger a pipeline, it will deploy. So we kind of just have to remember in the back of our minds not to trigger a manual build from our master branch, because it will deploy if we're inside of that group. We're kind of thinking about trying to come up with a way around that now using approvals. We haven't set that up yet, but that would be a way around the manual step as well. So you could still have auto deploy set to true, and then use some type of approvals underneath an environment, which we could specify that, say, there's a tech lead which can tick a checkbox to say, yep, go and do the deploy now. So we're kind of looking at doing that now. Property files management. So this was a big reason for having all of our properties in one repo, was to force code reviews on application properties. We also wanted a way to externalize properties for our environments. But having them all in one single repository means that all of the code reviews that happen, the PR checks are all going to be the same, right? So no secrets in plain text. Experience APIs that have been onboarded to our MuleSoft release repository should have a client ID, secured client secret, accessing downstream process of system APIs. All projects have a settings and property file for each environment that we can use for builds and Cloud Hub deploys. We also have a Cloud Hub default settings file. This is so not all applications need to duplicate the same settings. So what I mean by this is the region, worker size. So here at TrustPower, we basically deploy all our applications, especially in Dev and QA, using the minimum, which I think is 0.1 worker size, 1 workers, and the region is just set to our default of Australia's southeast, I think it is. And how do we enforce this is our next slide. One policy to rule them all. So when we originally set up the policy, as you can hopefully see by the path filter on this picture at the bottom here, we didn't have a path filter set up. So we were enforcing the policy across every folder and file, regardless of the environment that it was in. And it was slowing down development quite a bit. So we kind of felt like we were wasting time, in a sense, waiting for PRs to be completed. So the answer for this was we came up with the path filter expression. Just to the first / is just basically saying include everything, and then the other two is basically saying exclude QA and dev under our application folders. And one group means all reviewers should know or remember what to look for. So that basically means how the properties or settings can affect the pipeline at build and deploy time. So secure credentials and settings.xml file. Here at TrustPower, we use the endpoint CLI for most interactions with Cloud Hub. So in the pipeline, we need a way of authenticating. We do this using the credentials file. We use a single default profile inside of our credentials file, and we use tokenization to set up the environment. So we don't need to specify the environment in every PowerShell task that needs to use it. This was quite important for us because we found in every single PowerShell task we had to use a special export syntax to set up our environment variable. And it kind of got a little bit messy. If you forgot to set it, it would revert back to the default profile and then deploy your application to development, for example, which is not what we wanted. We use a connected application for authentication to Cloud Hub to perform tasks. The connected app needs to be set up with the correct scopes for whatever tasks you're wanting the CLI to achieve. So if you're wanting to deploy to Cloud Hub, obviously it needs that command under its scopes. inside of the access management section in access management, I believe it is, in Anypoint platform. Without that, it's you just get a 401 back from the Anypoint CLI. So our settings.xml file, hopefully we're all aware that the settings.xml file is how we bring through our dependencies. The way our settings.xml file is set up is everything is tokenized, just like our credentials file, which I think I forgot to mention before. So we tokenize all of our secrets into these files, and we pull them in from Key Vault, or we generate them as we need them. So what I mean by that is, for example, the settings.xml file can't use a connected application, we found. So instead of creating a native user, we just access Key Vault to grab our client ID, client secret of our connected application. We then send that through to I think it's a post API request, which returns us a Anypoint access token. We can use that token to access Exchange, and then our Azure DevOps artifact feed is set up to use a PAT token, which we just pull from Key Vault and inject that straight into the settings file. Our enterprise artifact just uses the standard, I think everyone's given a Nexus user or something like that. But one key note is that the access token we get from that API call, it does have an expiry, and we have found that certain tasks accessing Key Vault, sometimes they run quite quickly, so it might only take 2 minutes one day to retrieve all of the secrets that we need, and then the next day we've seen it take 40 minutes for some reason. We're still trying to figure why that is out, but it means that we have to be careful with reusing the token, which we don't do. We generate it new every time, and it's mainly for that reason of we can't guarantee the pipeline will run within the allocated time of that access token time to live. And we also, like I mentioned, we don't set up the access token as an output variable, so only the current job has access to it. So secret management with Azure Key Vault, this is basically our bread and butter of how we pull in and do everything to do with our tokenizing of credentials files, tokenizing our settings file, injecting secrets into our properties file. This is kind of what everything relies on in our pipeline. The key takeaway here is the secrets must be manually set up at this stage. So we haven't worked out a way of automating the setup. So when we're given a new application inside of our application onboarding, we haven't really worked out a good way of extracting those secrets yet and grabbing the name of what the secret needs to be and then creating that in Key Vault, and then potentially looking at trying to do some decryption around the local secrets. But that means we kind of need to know the local mule key, right? So we're still looking at how to do that particular part of it, but at the moment it's just the manual setup.
Hey John, sorry to interrupt. To interrupt, but we've lost your screen. We can't see your presentation anymore.
Oh.
Do you mind resharing, please?
Hoping that wasn't going to happen. I'll just stop sharing for a second, and then I'll share that same screen one. Is that all good? Can you guys see that?
Yep, I can see it now. Cool. Just wait to the chat if other people can see it. Yeah, looks like they can see it. Thanks.
Cool, Les. Okay. So so the scaffolding so the set up new application scaffolding, will create the Key Vault, sets up the access policy, and the Key Vault name is kind of automatically generated based on our repository name. We basically just remove the hyphens, cut off a certain amount of characters depending on what environment we need the Key Vault created in, and then we just output those as pipeline variables, which then get tokenized into the template parameters file, which I'll show you when I do the demo. At this stage, if you're wanting an application to talk directly to Key Vault, there was a mulesoft meetup a while back about DCR, which is Dynamic Client Registration. So if you're wanting your application to communicate directly with Key Vault and extract secrets and stuff like that, I'd highly recommend to go and check that out, because that would be useful inside of your onboarding a new application to set up the app registrations inside of Azure, so you can access the Key Vaults directly from your application. So we generally just use the Azure Key Vault task for accessing all secrets. The only place we don't do this is inside of our encryption task. That's kind of because we couldn't figure out a way to see what pipeline secrets were specific to the application and which weren't in order to encrypt them. So we had to use a PowerShell script for that, and then logically basically go and get the secrets from Key Vault, encrypt them, create them using the same secret name, and then we can tokenize our properties file using those secrets. Yeah. Cool. So DevOps permissions for service connections. So this is the way we can access our Azure Key Vault secrets. It provides us authentication, and the way the access policies are set up on these, I can show you when we do our demo. But basically, all of that is hard-coded inside the files. There's no secrets or anything like that. It's just object IDs, tenant IDs, and then an access policy list of what you can and can't do, sort of thing. And the permission for service connections is just around the new pipeline needs access to the service connections before it can use them. So if we don't set that up inside of our onboarding, then our application pipeline can't use the service connections. So basically no CI or CD will happen. The pipeline will just hang and sit there for a while and do nothing really, which isn't helpful for anyone. And if you don't have the right permissions on the project, you can't authorize the pipeline to use the service connections either, which is a bit of a pain. So it means you have to go in there manually and settle that out, which doesn't take too long, but it's just another manual task, so no one likes doing that. The secure config encryption tool, this is a big part of our security as well, in terms of we don't access the Key Vaults directly, so we needed a way to encrypt our secrets that we retrieve from Key Vault. And we use the secure config encryption tool for that. So we use it to mainly just encrypt secrets, not decrypt or anything yet. And when we extract our mule key from our pipeline Key Vault for the environment, we just need to supply a few extra arguments along with that. So whether we want to encrypt or decrypt, the algorithm and the mode, the mule key and the secret, of course. We can use this for files or strings, but at Trustpower, we just use it for strings. We don't really do anything with secure files at all. Once the secrets have been encrypted, we just do tokenization on our properties file. And that is basically how our secure properties are handled from Azure Key Vault. We extract all the secrets from the application Key Vault, we encrypt them using this tool, and then we tokenize our properties file. And we basically do the same for credentials and settings, but just without the encryption. So how do we find the arguments that the secure properties tool needs? This is where we interrogate our application.settings file for each environment. So we've got an application.settings file and a default.settings file. The files will tell us the algorithm and mode that we want to use, or at least the default. And then we can use the global configs XML to override them if it differs from our Trustpower standard. So the reason it was set up like we've had to set it up like this is because mulesoft by default, the secure config module, I believe it is, if it's set to AES and CBC, so AES is just the algorithm for encryption, it doesn't display that inside the global -configs.xml file. So we needed a way to set that for the encryption tool that I just mentioned before. So without having that default inside of our application or default.settings file for our environment, we were kind of struggling to find a way of doing that unless we just hard coded, which we didn't want to do because that's bad practice. So that was just our way of being able to specify defaults, and if mulesoft ever decided to change the default, that's where we would change it inside of that environment default settings file. Yeah, that's sort of all about that one. SLA tiers is kind of the last thing about pipeline security. So it's nothing to do with pipeline security itself, but more about the security that the pipeline does in terms of for the application that we're deploying. So every time we deploy an application, it will go through and deploy the SLA tiers. This is enforced by a automated policy for each of our Cloud Hub environments, well, not Cloud Hub environments, API Manager environments. So our pipeline sets up some security for our mule applications. If the application property file has an API Manager auto discovery ID, that's when we use the ID to set up the default SLA tiers for our application. And we just do that for the simple reason of when a user is requesting access to our API Manager API, they can just select their desired SLA tier. So at the moment, we've only got a default SLA tier for each environment. And it's just, I think it's 100 requests per second or something like that. And we just do this to make sure that no one can just start hammering our APIs and do anything malicious with them. But you need a client ID and secret anyway, so we should be good. That leads me into demo time. So for this, I will just try and drag across what I've already got here. And we'll see if that'll work. Okay. Cool. So hopefully you guys can all see the Visual Studio code. Can everyone see that?
Yep, I can see it.
Cool. Sweet. So like I was hopefully mentioned before, and in case I went too quickly and forgot it, was our applications folder. This is the main one that all of our onboarded applications get added to. So these are all of our current applications that exist inside of our MuleSoft Cloud Hub environment, which might not be a lot compared to some of you, but we're getting there. Basically, the way this happens is we've got a scaffolding folder set up. So we've got a whole bunch of scaffolding that happens in terms of the artifact name, the repo name, and how they all match. This also matches inside of here as well. So if you want to have a look at application properties or whatever, you just have to come in here and find your repository name, and then you're good to go, and just click on whichever environment you want to look at. So our scaffolding applications folders are set up pretty simply. So we've just got a key vault name in each one of them. The reason why we've got this is mainly because our Cloud Hub environment has our main default set up. So at this point here, we can use this application.settings file to override any of our defaults. So our application.settings file specifically can override our key vault name and set up that's how we set up our key vault secrets for each application. So we can also override the region, worker size, and workers, our auto deploy that I spoke about, our secure config algorithms. So That'll happen if we change the default. If mulesoft change the default, sorry, this is where we would have to update it. Otherwise, we can pull it in from our global-configs file. And the SLA tiers I spoke about that are auto-deployed with each application, this is where we read them in from. It's pretty much the exact same structure that's sent through to the API, because we wanted a way of developers to be able to set everything. So, for example, our dev environment, we've got auto-approved set to true, but for our production environment, default.settings, auto-approved set to false. So it just means that development, once again, we can get a lot quicker development done then, not having to wait for someone to manually approve our requests to access the API through API Manager. So that's our application environment Cloud Hub files. Hopefully everyone's still following. So all the others are just the same. It's just the environments that differ slightly. And then we've got our key vault scaffolding. So our key vault scaffolding is basically just template parameter files. And then we just tokenize in our key vault name. And then a review date, a lifecycle date, which are just tags. So they're just set on side of our Azure resources as tags. And then this is how we set up our access policy for our service connection. So we've got a tenant ID, which is hard-coded in here. It's not a security issue at all. I just thought I'd asterisk that out because it's possibly going on YouTube or whatever. So I thought that might be the best practice to do. Our object ID is just our service connection object ID that we've already created inside of Azure. So they already exist for us. So if someone else was wanting to set this up, when you create an application registration, this is where you could put your object ID inside of a parameters file. And then we've just got our permissions for keys, secrets, and certificates, storage as well. But we just use Azure Key Vault for secrets inside of all of our MuleSoft applications. The other access policy here is just for our Azure owners, so it's not really a big thing to focus on. You might have an owners group that you want to set default permissions for as well. This is just so that, for example, I'm in this group, so I can go into the Key Vault and manually set up secrets and do all that type of tech-opsy sort of stuff to get the pipeline working. And there, each one of these parameters file during the scaffolding phase is passed into a generic TrustPower template. So it's not in this repository because we've got a different template repository for that. And it's literally just like a stock standard Key Vault setup with our particular security configurations and stuff like that. And then we just pipe in our parameters file to that. The secure files is basically just our tokenized, or untokenized, I should say, credentials and stuff set up. So here's our default profile that I mentioned before. We've got the client ID, client secret, and the environment. And this is just how we set up our tokenization. So when we come to a replace tokens task, which I'll show you in a minute, as long as the pipeline has a variable setup that matches each of these, they will be swapped out for whatever the variable is set to. And those are all pulled out from Key Vault just before the replace tokens task is run. And it's pretty much the same with our settings.xml file. So we've got a DevOps pat token inside of our Azure Key Vault, for example. We generate the anypoint access token just before the replace tokens task. And then we've got a native username and password for our Nexus Enterprise repository. So now into the pipeline templates. We've got our main, I'll start off with our onboarding a new application. Looks kind of big and ugly at the moment because we haven't set up our PowerShell files to be files, so they're all inline scripts at the moment still. It was created quite a while ago, so I probably should have done that by now, but it's just hard to find the time sometimes. So we've just got the parameters and stuff, which is just the project name, repo name, and our branch reference. the branch reference just comes through as like refs head master or refs head feature, something like that. Generally, it should always be a feature branch because we shouldn't be adding to master or develop branches. We set up a whole bunch of default variables. This is how we pull in our mulesoft release repository. And this is where we get our ARM templates from. So we've got a project called Azure with a repo called ARM templates. And this is what we use to pass in our ARM parameters files. We've got a small job to validate the project, but that's just checking whether the folder exists or not. Otherwise, it will throw an error if we didn't have that there, because it was trying to duplicate applications or folders that already existed. So set up the application key vaults. It just does real simple kind of stuff here for the name, for example. So key vaults have got a character limit for the name. So before we can create the key vault, we first have to come up with the key vault names. So inside of here, we've just got some, we'll split up the app name array first. We just got some environments. We loop through each one of these environments, and we're basically trying to work out what our app name can be from here. We kind of have to modify this a little bit now because we've realized that our domain and subdomains, depending on how long they can be. So for example, Salesforce is quite a long domain name. So some of our Salesforce key vaults won't be created because it will have the same name. So we just have to come up with a way of trying to add some randomization to that, or trying to shorten down our domain names. So Salesforce would be a domain name, service orders would be a subdomain, for example. Here we're just specifying or trying to work out what the layer is. So POC, System API, Process API, Experience API. We just do this for our resource group. So in Azure, they have resource groups, which are just big containers, and you can just go and throw all your stuff inside of a container. And that's just telling it which resource group we want it to live in. So the ARM template parameter file that I showed you before has a review date and a lifecycle date. So this is how we're working that out inside of PowerShell and setting up the pipeline variables for that. And this is how we set up the resource group variables for dev, QA, and production. This is the replace tokens task, which is probably one of our more important tasks aside from key vault in our onboarding application and our general application pipeline. So this is basically looking under the scaffolding key vault file we've seen before in here. It's then going to grab all of our parameters dash wildcard files, so all of these, and it's then going to try and tokenize them using this token prefix and the token suffix. So for example, we've got the review date here. If we go and have a look in here, the review date is here. So as long as that exists before that task is called, that'll get tokenized into that file. It's not a secret, but it is just a way of being able to, because what is it? The ARM templates don't have any functions yet for specifying or working out what the current date is and what 6 months from now is going to be. So we have to use PowerShell for that type of stuff. This is just a this is how we deploy our key vaults using the key vault names that we've worked out up here, which are just in here. And then it's basically saying the resource group name is this. We want to create or update the resource group. This is our template. This is our parameters file that we've just detokenized. And then we just pass through those arguments to it. So this here, the resource manager connection, this is our service connection that I mentioned in the PowerPoint slides before. Without this, we won't be able to access key vault. So this is where this access policy stuff has already been set up for that connection. So what I mean by that is this service connection already exists, but we also use the same service connection because it's still pipeline to access our application key vaults. And those are all basically doing the same thing, just for different environments. So development, QA, production, and pre-production. The setup MuleSoft release job. This is what we use to set up our onboarding. So this is how, for example, we can create an application beneath here. This is the job that will do it. So we just need to know the key vault names for tokenizing into our properties file. For example, not there, in here, we've got a TPW secure config POC kv-dev. So we just tokenize our scaffolding file in here, and that's how it gets put in using that replace task. So this is just checking out that resource figure up here, our MuleSoft release repository. It's telling it that if there's any cached stuff, just remove it. Any cached git commits or anything like that, just don't worry about them. The persist credentials here is quite important because we need to use the access token to update, basically push our new commit in, because we're adding a folder to our MuleSoft release repo. This is just copying the scaffolding files to where they need to be in order for our setup. And then we just go through and use our replace tokens task that I mentioned before with the same prefix and suffix that we've seen. And then the last sort of step would be to set up the MuleSoft application. So this would be our target repository. The script here is doing quite a bit of work, and it does look somewhat like it kind of almost needs to be simplified or turned into functions or something, but it can be a little bit difficult. So all we're doing here is just copying our application pipeline file to our application itself. We're then just doing a git add, git commit, git push for adding the pipeline file. This is just setting up a default header for the authorization for our Azure DevOps calls that we need to make. This one here is just adding the build service to the MuleSoft pipelines team group so it has access. And then this one here is just updating the MuleSoft pipelines team URL. So once again, this is kind of adding the newly created build service to the MuleSoft pipelines repository. So where this repository exists inside of Azure DevOps, that's where it's adding the build service to get permissions to be able to see these pipeline template files in here. This call here, which is quite big, is just doing the creation of the pipeline key vault using the application pipeline that we've copied over. And then this one here is just basically allowing our pipeline to access the service connections so that when the triggers are hit, they're not just waiting, hanging for authorization to resources, and they will just hopefully start running and everything will be fine, which is working good so far. So that's our onboarding application pipeline. Is there any questions around that?
We've got a few questions. Yeah. Most of the questions are coming from Jules, our resident DevOps guy. So first question, have you had any luck removing app and redeploying for runtime version change or property removal? I think it's redeploying the app.
Are you talking about wanting to remove an application from
Sorry, Sean, what was that?
Was the question about trying to, have I ever tried to remove an application from Cloud Hub?
Yeah, for runtime version change or property removal.
So we don't do that for runtime version. Can you just mute for a second, Joy?
Sorry? Can you
Would you be able to mute for a second? It keeps going back and forth, sorry. So we don't really delete applications when we do a runtime version update. We do delete applications as part of our rollback, which isn't working yet because of the, when we deploy an application, we get the incorrect result back from the CLI for the previously deployed application. So we can't rely on that to set up our rollbacks. And for our runtime version updates, like going from mule 4.2.2 to mule 4.3, we don't do anything in terms of, the pipeline doesn't handle that at all. So that's all pulled through from our configuration, our pom.xml file, sorry. So if I bring up, hopefully you guys can see that. If I bring up our pom.xml, please come up. So we just grab our runtime from here inside of our pipeline, which I can show you in a minute. We just use like a PowerShell XML parser, and we just pull our runtime from here and use that to set whatever runtime we need it to be. So we have to update our application, applications POM file, if we want to update our Cloud Hub version inside of there. Well, did that answer the question, hopefully?
Let me unmute Jules. Hey, Jules. Hey, Jules, you could unmute. Does that answer your question?
Hey, Joy, I don't think I can join the voice, join the audio. It's only the host who can do it. And even if you do make him host, he probably won't have access to it. That's my understanding.
So it's all good. So the next question is, have you considered gated releasing? The deferral is a nice Azure DevOps feature.
Yeah, so that's what we are trying to do now. We have spoke about that. I think to do like gated releases or like an approval step, we have to use an environment. So the environment section is slightly different, or at least needs a different YAML file inside of Azure DevOps. We have looked into that, and there is other pipelines in TrustPower that are using that. As far as the gates go, I think they can be used on any pipeline, not inside of an environment pipeline. But we haven't looked into that too much yet, but we could do something like that for Immunit or something, like there has to be a 75% test case coverage to do that. We have looked at approvals, like I said, for maybe tech leads to approve releases going into production, but there's no UI for the YAML pipelines that would pop up the approval, which is why we'd have to use a different setup. So when I say it's got like an environment, Azure DevOps has got a notion of pipelines, and environment is different to pipelines. So you have to create a new YAML file and set that up differently to be able to access the approvals of that. We are looking at trying to do that though. Is there any other questions before I carry on? Cool. That's all good. So inside of our pipeline templates, we've got an application-pipeline file. Oh, sorry, I see people are having trouble hearing me. Can everyone hear me fine now? Okay.
Yep, we can hear you okay now.
So I'll keep going. So we've got our application pipeline file. This is what gets added to every target repository that comes up. So basically every mule application repository, and it gets added only to feature branches. So this is because of that whole policy around master and develop that we have set up. So if we were to try and add this pipeline file to a master or develop branch, we basically get told, no, go away. This is fairly straightforward and simple. We've just got our repository resource for our templates set up here, and then we just refer to that inside of all our templates in here. So at the moment, the way that's set up is that a developer can come in here and modify this, but then our service hooks and logic apps will switch it back to what it was. So we haven't come up with a way yet of having a developer to not modify this file at all unless we specify a specific policy for every mulesoft application, which is what we're looking at doing or have looked into. We just haven't got there yet. So that would force developers to need a PR in order to update the application-pipeline file. But we also need a way of, because we use the uniqueness of the file to stop the automation, if people did want to update the application-pipeline file for whatever reason, we'd have to come up with a way to then stop that automation loop. Otherwise, it's going to be stuck in like a forever loop, which wouldn't be good. So I'll jump into our stage of step templates first, because this is quite a important one. This is how we set up our mule key. So we use what's called a step template inside of Azure DevOps pipelines. So basically, we've got a whole bunch of predefined steps set up, which we pull in some secrets depending on our environment. So we've got an environment variable, which we can access. I'll just show you inside of here. So this task here prints out an environment variable. Is our variable name there. And every stage refers to this and pulls this in. So I'll just click on build to start with and scroll right to the top so you can see that. So for example, this is creating a stage variable for our environment variable, and it just pulls in from that task. So where's it gone? Set up mule key. So every stage that uses this must have this variable, and then the variable must equal one of these. And this is what we use to pull through the mule key for the environment and set up our service principal, client ID, client secret, and tenant ID. We need all of these because we have to check our application key vault to see if that has its own mule key in there. So what I said earlier on in the presentation about having a dynamic mule key is that each application at the moment can have a different mule key. Currently, all applications are using the default for dev, QA, and production, but there is the possibility there that we can change them if we ever thought there was a security concern around that. And we have to use a PowerShell task to do that because we have to check the application key vault to see if it has a mule key first to bring it in, and then set up that mule key using the string, the mule key string, which we grab from here. So if the secret contains mule key, this is for an application key vault, sorry. We'll just make sure everyone understands that. If it contains mule key, go and grab the secret, convert it to plain text, and store it inside of a variable called mule key. Important thing to note here is that we do this at the job, well, at the step level inside of a job, so then no other stages or jobs can access this variable. So before we had it set up inside of our get environment settings, coming down here inside of our setup environment. This wasn't app name, this was setup environment variables. And we were outputting our mule key here. And then our other stages, we're grabbing it from this task here. But then we found that inside of the application pipeline file, I can just add another stage in here to basically print that mule key to a text file, for example. I can't print it to the console because it gets tokenized because it's a secret variable in Azure DevOps, not a normal variable, not a plain text variable. So that's just the key thing to note there, is that's why we've made that its own sort of step template, was just to remove the security concern around having the mule key being accessed by people that shouldn't be able to access it. One of the reasons for that as well was because when our application does a build and creates the jar file, we publish that artifacts to pipeline artifacts, and our deploy stage will go and grab that file. So when we publish that jar file, our developers can get access to that because they have access to the pipeline. So if they can access that, and then they can access the mule key, they could change, go and decrypt using the secure config encryption tool, and then see all the secrets in plain text if they wanted to. Hopefully they haven't done that ever before, or would ever do that. But that was just one of the concerns around people potentially being able to do that. So that's one of the key sort of areas that we did there with our mule key. So currently, as it stands, is that they could access the jar file, but you wouldn't be able to do anything with the encrypted secrets there. You wouldn't even be able to run it because you need the mule key. So it would just complain if you were to try and run it using the production environment global configuration variable that you pass through when you run it. It would just complain and say the mule key doesn't match or something like that, which is quite cool. So our get environment settings, this is our stage templates now. So we've got three main stages. We've got get environment settings, build, and deploy. So get environment settings basically just does all of our application pipeline initialization and setup. So this is just grabbing our dev files, for example, for this one, splitting them out into our standard default working directory, into the environment folder, and we then just set up an environment variable. So this environment variable for every one of these tasks is pulled in from down here. And then we just basically say that whichever one isn't matching this, we want to set our environment to be that. This is so we can refer to one task. So every stage will refer to this task to pull through the environment. So you'll see later on that there's a way that you think inside of this application pipeline, we pass in parameters environment. So if I was to change this to prod, it doesn't mean that that's going to deploy to prod at all. It just means that if all the checks and balances pass, then it will. But but it doesn't mean that it will actually deploy to there unless those checks are done. So this is quite an important task here, but it's also used with the pipeline parameters. So all of those are the same. This is just publishing that artifact that we've created. So this is our settings artifact. This will contain our, I believe, credentials files, secure config, credentials files, settings.xml, and that's it, I believe. The pipeline variable step here, this is basically just setting up our application and pipeline key vaults, because we need them at different stages. We need to access different key vaults. So at the build stage, we might need to bring in some client ID, client secret to be able to access the application key vault in a PowerShell script using Azure, the AZ module inside of PowerShell. And set up environment app name. This is where our deploy step basically refers to this. I originally created it here because I thought we were going to need it across multiple stages, but it's only needed inside of the deploy stage. So this is something that we can move to just that stage, I believe. And that's as simple as our get environment settings is. It just grabs a whole bunch of files, sets up an environment variable, and sets up the application name and key vault names to be able to be used or referred to later on. So the build stage. The build stage is referring to our application and pipeline key vault and our environment variables inside the stage. So all jobs inside of the stage have access to these variables here. We've then got the setup, the project files job, which basically just does exactly that. Validate the POM file. It just does some simple checks here using these variables here. So group ID, packaging, munit plugin, minimum required coverage, fail the build if the coverage isn't met. And we basically just check before we validate anything to do with munit if the POM file has the munit plugin inside of it first. So we do that using the XML project build plugins.plugin. So that's how we can get access to our XML. I believe we read in the file further up here. So that's just how we can get access to those the plugins that the POM XML has for the configuration for munit. This is just our generic checks to make sure the artifact ID matches their repository ID, making sure the group ID matches what the Trustpower standard is, and then just some simple checks for the description, making sure the name matches the repository name, and making sure the packaging matches mule application, I believe it is, yeah. So that's quite a simple sort of a script there, not doing anything too major. This one here is this is one of the main steps in this whole pipeline here. So this is what handles the retrieving the secrets from a application key vault. It will also encrypt the secrets, and then the following task uses what this outputs to tokenize the or detokenize the environment properties file. Excuse me. So this one here, we're just reading in the settings file. So this line here is basically just overriding the key vault name. So we've got a pipeline key vault and an application key vault. In this particular task here, we want to be looking at the application key vault. So we just override that with the defaults. We do the same thing if we want to use the application.settings file to overwrite like the region or the workers or the worker size. We will do something similar to this little function right here. So this bit here is where we kind of pull out or extract all of our encryption info. So this is needed for the secure config tool that I spoke about earlier on. This is where we set up our XML object, if you will, read in our global configs file. This is doing some just XML namespace stuff so we can get access to it. And then this settings file that we've got further up here, if that is set, so if our encryption info is not equal to null here, this is what we use to override our algorithm and load. If it's not, then this doesn't get run. So this is how we set our defaults. This is just installing the AZ module and connecting to the account, grabbing the secrets, and then we basically just loop through every secret inside the key vault. We don't need to encrypt the mule key if it does exist inside the application key vault. So that's how we can adjust the mule key per application. So it can be different from the environment mule key. And yeah, it's just a waste of time encrypting that. So that's why we've got that, that secret.name is like mule key. Then just continue.
Sorry, Sean. Sorry to interrupt you. Would you be able to zoom in?
Yeah. How's that? Yeah. Zoom in. Where's the zoom button? I have got no idea how to zoom on this.
Go to view.
Yeah. Appearance. Zoom in. control plus equals. Oh, that's probably a bit too much. Is that more readable? Or would you like me to go on a bit more?
Actually blurry from my end. I'm not sure with you guys. Is it clear at your end, Rao? Rao Cod? Yep, better.
Yep, is that, should I carry on?
Yes, thanks, Sean.
Cool, as sorry about that, guys. I didn't realize it was clear. So yeah, we looped through all of our secrets, excluding the mule key. This is just the command we used to go and get the secret name. We then go and get the secret text from the secret we've just gone and grabbed. And this encrypted value is what is returned from our secure properties tool, which is inside of our library up here. I forgot to mention that before. So the library folder just has our secure properties tool.jar inside of it there. We use that jar to pass in our algorithm, our mode. We want to pass a string. We want to tell it to encrypt. And then we've got our mule key string followed by our secret value text, which is just the secret in plain text. We store that inside of the encrypted variable, encrypted value variable, sorry, and then we just output that inside of the as a pipeline variable. But notice here we have to output it inside of the square brackets with the, I think it's called bang notation at the front prefixed to it. That's just a or else statement saying no app settings file found, so bad request. And this is the replace, oh sorry, so I should probably ask if everyone understood that first, because that's quite an important step in our secure DevOps pipeline. I think I don't see any questions coming through. I think it's all good. So the replace tokens task is just using all of the secrets that we've set up and encrypted in here. And then we just go through and detokenize the properties file. So if I bring up the secure config dev dash properties, we've got something here called my secure property with a secret value text. So inside of our key vault, we would just have a secret set up, and the name of the secret would just match this. And then our pipeline uses that key vault secret name and outputs that to the, and outputs that as the variable name. So that's what we've got here. There's a secret.name. This is how it uses the key vault secret names to tokenize the file. So they both have to match from our local dev properties or environment properties file, have to match the key vault secret name in order for the tokenization to work. We then just set up copy the files into the correct directory. And then we go ahead and do our build. So our properties file that's been tokenized is fine to set up inside of our, detokenized I should say, is fine to set up inside of our artifacts, as I say, because everything's encrypted, and the only way you can get access to that is through our mule key. And because our mule key is hidden away beneath our step templates, no one can access it. So that's fine as it is there. The download artifacts is just bringing through the files that we've set up. So the tokenized properties file, the application.settings file, and it brings through the untokenized secure files as well. This is just setting up some pipeline secrets that are needed to detokenize the settings.xml file. So the DevOps pat token that I mentioned before inside of our settings.xml, that's where it gets it from. I'll go back to the build stage. The Cloud Hub client ID, client secret, Those are both needed for generating the endpoint access token that we put inside of our settings file as well. That's how that's generated, which I'll show you in the next task just below these ones. And the enterprise artifact and username is just brought in from the environment that that key vault is into. So production, QA, or development, we just go into those key vaults and pull them out. And they get tokenized in there. So we have a PowerShell task called generate endpoint access token. And that's a pretty good name for what it does. It just sends through a post request to the token endpoint with the client ID and client secret. We then get a Vera result, and we output that as the access endpoint access token. And we just make sure we set that to is secret true in case anyone does accidentally output that touches the file, which they shouldn't do. We then just run our replace token step again, which we then just go through and detokenize this settings.xml file. We're setting up our mule key, so this is how we reference our stage step templates. So that's just telling it that we want to use the setup mule key from our templates resource, which is referring basically to itself in here. Well, this is an application pipeline file, so the target repository is referencing this repository. And like I mentioned before, we use the build application PowerShell. We use PowerShell to build the application because the Maven task was outputting the mule key in plain text. And the arguments we give it are just basically telling it to, in case we ever want to change the POM location, which we've never had to, we can do it using the parameters.pom location, which is up at the top there. And then this is how we tell it which settings file to use. So because we've gone through and set up a new settings.xml file with the credentials inside of it that they need to pull through the dependency, that's how we refer to that. And this is how we set the mule environment, which is quite important. So that makes sure that we're looking at the correct properties file when we build or try to build our application. And the mule key string is important because that's what it needs to decrypt the values. So this is where munit's quite important, we found, to bring any errors forward at the build stage, so we don't run into them at the deploy stage when CloudHub tries to run them. So as well as testing being good and needed inside the CI step of a pipeline, it's also handy for bringing errors or bring them to the forefront before a deploy happens, which is very handy. You can save on a bit of time. This is just basically copying the mule application jar file that's created from our clean package step. And then this just outputs everything inside of our artifact staging directory inside of a drop artifact. Is there any questions about that job, those jobs? Don't think so. Sweet. I'll carry on to the deploy. I can probably get rid of that now too, and then go to deploy. Okay. So, like I mentioned in the PowerPoint presentation, what I should refer to as well as this one down here. So we use the same template for all environments, and the reason we do that is because we don't want to duplicate any, basically it's all the same, it's only the environment that changes. But how can we stop people from deploying to specific environments? Like how can we stop someone here from just wanting to deploy to production, for example? So this is where our pipeline conditions come in handy. So pipeline conditions, we've got this depends on, which basically just tells it to wait until both of these jobs are finished or stages are finished. Once they're finished, they both must succeed. As long as they both succeed, we then go and check the source branch to see if it matches feature or, starts with feature. And then we check the environment variable or parameter environment matches this environment here. The reason why we can't use the environment variable here yet is because which is created inside of here. If you guys remember in this step here, we can't refer to that inside of a stage condition, which is what this is. So although we can pull our environment variable through here, we can't refer to this variable that's been created inside of here. So that's why we've had to pass in environment parameters. But we've also done that because we get a nice output of what environments have been deployed to and haven't been deployed to inside of the pipeline execution, the UI that we see. I'll show you that in a minute. And then the other checks are just doing something similar. So making sure if it's develop, if the source branch is equal to develop, make sure the parameters.environment equals QA. And that's just how we stop people from deploying to environments they shouldn't be able to. The pipeline variables set up here are similar to build. So pipeline key vault, app key vault, environment. The only extra one here is the anypoint CLI version. So this is how we can tell it to always use the same version. So if there's any updates that happen and commands are changed at any point, this is kind of how we can stop that, which is good to do. So the very first job is to determine the authorization. So if whoever triggered the pipeline is allowed to trigger it to do a deploy, or if the auto deploy flag has been set. So no checkouts, download our settings artifact, and this set can proceed is basically just doing that. We've got an OK to proceed variable. We then go and grab our default settings and our auto deploy. We grab our application settings and we check if that has an auto deploy variable set. If it does, we override the application auto deploy with the application one. Hopefully that makes sense. So this would be our pipeline auto deploy, and then this would be overriding it with our application auto deploy. And this is just basically saying that if auto deploy has been set to false, we want to see if the person that triggered the pipeline has permission to do a deploy. So as long as if auto deploy is set to true, this won't run regardless of who triggered the pipeline for the application. Kind of a key point there is that we do need to put gates or approvals in at some stage would be nice, but that's the way we can have a full CI/CD pipeline is by using that auto deploy and by using the group membership to overwrite that for production, because we don't have auto deploys set to true at all for any production applications. The URL and this first bit here is just basically going away and getting everyone that's a member of the MuleSoft Pipelines Release Administrator group. So inside of Azure DevOps, there's a section called Project Settings. You can go to Permissions, and then under Permissions, it's basically groups. So you've got contributors, readers, that type of thing, endpoint administrators, release administrators. We use the release administrators group to be able to override the auto deploy flag if it's been set to false, so that myself and a couple of other people can deploy to production. And basically that's what this first step here is doing, is going away and getting all of the members and then looping through the members to say, are they equal to whoever queued the build? So if it was a CI trigger, if someone's completed a PR, for example, that would come through as just, I think it's like a Microsoft service account. So that would never be hit. If I was to manually trigger the pipeline, my name would come through here and it would equal the display name. So it would set OK to proceed to true. If auto deploy was set to true here, this would be false and would then set our OK to proceed to true. And the last step here is just outputting that variable, that OK to proceed variable, as our OK to deploy. Our other jobs basically just rely on each other from here on out. So the initialized deploy looks at that OK to deploy, sees if it's true, download the artifact, settings artifact. This step here is just setting up the deploy variable. So reading in our settings file again, overwriting values based on application settings versus environment settings. This is how we, I think someone asked the question before about how we set our runtime version. This is how we grab our runtime version. So we read in the XML pom.xml file, sorry, and then we use a regex pattern to search or to pull out the matches of the application .version, I believe it is. So further over here, oh, there we go, no property runtime, there's no property matches at position 0. So this bit here is telling us to target our app.runtime, which is this one here. And then it's just saying if there's no matches found, we can't do a deploy, so error out. Otherwise, we have found matches. We want the very first match that we found. And then we just add that to our settings object that we've written from our application settings and default settings. This is just setting up our Cloud Hub environment that we want to deploy to. So earlier on, I mentioned that our credentials file gets an environment tokenized into it. And this is how we set that up. So we use our environment variable that's created from our initialization task in here. And we then just basically specify what our Cloud Hub environment should be. So if it's QA, pre-prod, or prod. And then we just output as a variable. This isn't a secret variable, so there's no reason to say is secret equals true or anything like that. There's no real issue with outputting that. And then that's used later on in our deploy job. So we just set up these variables for our job. Got some base URIs here. We set up the runtime, workers, and worker size region, which is pulled in from our default settings file, region, workers, worker size. And then the Cloud Hub environment, which was created up here. We then just download our artifact, set up our Azure key vaults for the Cloud Hub client ID, client secret. So these two are both for the credentials file. The Splunk token, Anypoint Platform Client ID, and Anypoint Platform Client Secret are specific to the environments. So we've got one Cloud Hub Client ID and Secret that we use for Dev, QA, and production because we only thought we needed one connected application for our Azure DevOps pipelines. The Splunk token, so each of our applications have got a Splunk token global configuration or global property set up there. And we use these last two as arguments to our CLI deploy command that I mentioned earlier on, which I can show you in just a minute. So this is just doing the tokenization of our credentials file using what we've just pulled in. And then this is doing some setup for our Anypoint CLI and variables. So like I mentioned before about setting the set up the credentials file, if you have multiple profiles inside of there, so we use default, but if you wanted to have development, QA, production, and that type carry on, every single PowerShell task that runs the Anypoint CLI command would have to set its own environment variable, which can be a little bit taxing if you forget you can deploy a production application to development, for example, by accident, which we don't really want that happening. So we just thought it would be easier to set up the default profile and tokenize in our Cloud Hub environment. So we just install the Anypoint CLI. We set up our Cloud Hub profile, which is just our credentials file inside of the anypoint.anypoint folder. We go away and create a new Vera token because of the potential Azure module inside of PowerShell can take a while to bring through some of the settings sometimes. So we just generate a new one each time we need to use it. Set up the environment and organization ID. This is just getting some apps to see our command. So like I mentioned inside the PowerPoint presentation is when we do a deploy, we have to change the command to be deploy or modify based on whether an application exists or not. This is just reading in the environment properties file, which isn't too That's probably the most important piece of this lines here is just our auto discovery ID for setting up our SLA tiers at deployment time, just after we deploy an application. And this is just checking that if we can find it, grab the first match that we find inside of our properties YAML file. And the reason why we kind of had to do it that way is purely because of PowerShell doesn't have a good way of reading in YAML files without using the third-party module. So I haven't really been able to find anything, a better way of doing that. So we just use a regex pattern for extracting that for now. And then we just set up the variables as pipeline secrets that we've found in here that we've been able to find. The setup, the rollback application, at the moment, sorry, this is still running but not needed. So at the end of this deploy YAML, I'll show you our rollback, but it's not actually being used because we have to query the anypoint CLI application describe command instead, because the deploy and modifiers return us the incorrect state of the application, or can return us the incorrect result. So this is just setting up the mule key using the step template, and then we deploy our application here. So this is just grabbing the jar file pattern, or finding the jar file using the pattern. This is setting up the command, so whether it is a deploy or modify, and then we just have to make sure that if the application exists, that we remember to start the application before we try and deploy to it, otherwise we get an error. This one here is just deploying our application, but this is where we also pass in our runtime that we've found before, the workers from our environment Cloud Hub default.settings file. So all of the stuff is pulled in from there. We set up the mule environment, the mule key over here, the Splunk token that we found before further up. And then this is just setting up some client ID, client secret, and then the base URIs that were defined right at the top of the stage, as well as specifying the application name that we want to deploy, which was generated inside of our get environment settings file. And this is just specifying the jar name that it should use to deploy. We've got a simple error check here, which this will say the pipeline failed to deploy if the deploy or modify command returns an error. But like I've said, that if the application was already in an error state and we deploy a successful application and it can run fine, we can hit fire request at it and get successful responses. It will still return the error from the previously deployed application, which is kind of annoying. So this other stuff here is kind of just setting up the application URL to be used inside of an API manager task further down. So we need to do this so we can automate the API manager implementation URL. We use a Cloud Hub put request to disable, or I guess enable custom log4j. And then the next stages down here are just update API manager, next task I should say, update the API manager implementation URL, which we've got from this part here, creating that pipeline variable. We then use that in here and just basically say, go away and update that. If we have an error, throw an error in the pipeline, otherwise successfully updated. And then we've got our create API manager SLA tiers. So at no point in our pipeline do we actually create API manager. That's still a manual step. So we have to manually get the auto discovery ID and add that in. Generally, we do that when we set up the API manager auto discovery inside of the global configs. We'll go and do that for all environments and then add those auto discovery IDs into the properties file. And then all of this just sort of works as it should. So this one here is just setting up the headers with the endpoint access token. This is just setting up the API manager URLs that we need to hit. This is the function that we use to create SLA tiers, which is just using the SLA tiers, which are defined inside of this default.settings file. So if there's 20 SLA tiers in here, it'll deploy 20 SLA tiers. If there's one, it'll deploy one. And yeah, that's basically all it's doing here. It's just basically saying get the content from default settings. If there's any application SLA tiers, grab those. We want to then go and just create the SLA tiers for both, well, first of all, the pipeline SLA tiers or the default environment SLA tiers, and then the application specific SLA tiers. So if you wanted to overwrite SLA tiers or anything else inside of here, we can just come and specify it inside of this application.settings file for the environment, for the application, underneath the applications folder. This next job is set to false to not deploy for now because, like I said, the incorrect response from the CLI commands, but basically all it was doing was just creating a rollback application, which is what this one here was doing. So this one here was just saying, so delete the application, create a copy of the application. Here we go. So this is basically just saying create a rollback app, giving it a name, and then what application we want to copy. And then this one here is basically just saying to go and delete the rollback application after we've rolled back. That is our pipeline, everything there. Is there any questions to finish that off?
Sean, you're good.
We're good? Cool, lads. So I think there was one last point slide, or a couple. So pipeline improvements we can make. Yep, so we've already done this. Use a step template for generating the mule key. Remove some inline scripting, so changing all the PowerShell tasks to use files instead of inline. Make some of the PowerShell tasks a little bit more smaller and more understandable, readable. Automate setting up API manager would be a very cool one, so that would remove some manual steps. This one here is kind of important too. So at the moment, if developers are flicking through quite a few git push with commits and stuff, will trigger the pipeline multiple times. So if you send through, say, 10 git pushes, it will trigger the pipeline 10 times, and then it kind of uses up all of our Azure DevOps agents, which is not cool because everyone kind of gets a bit annoyed with that. And like I've said here, use of approval gates for environments. So especially for production, that would be real handy to have. And then we've just got some key takeaways of what we've hopefully learned. So hopefully everyone's picked up something helpful from there or found some new things that they can go and implement. Yeah, thanks guys.
Thanks, Sean. So is my audio all right now? Like, is it still echoing?
No, that's fine now.
Okay, cool. So yeah, great presentation. That's quite a lot to digest, so I have to watch the recording. Yeah, so let's jump onto the quiz. Yeah, trivia games. So we're gonna pick 3 winners who will get certification voucher or exam voucher. Exam voucher or training voucher. Yep, we'll upload the recording, Francis. Yep. Cool. So yeah, you could ask question now, Sean. What's your first question?
Okay. Where was it? There we go. Choice level and scroll up a little bit. Just gotta find them, sorry. Here we go, cool. So how can we remove secrets from our secure files?
The question again, Sean?
Yep, so how can we remove secrets from our secure files?
So any answer, guys? So Erwin said putting into secure vault.
Yep, and tokenization. So key vault and tokenization.
All right, sweet. So Erwin is our first winner. So question number 2.
Question number 2. How can we access the secrets? It might be a bit of a hard one because I didn't discuss it too much, but hopefully someone was picked up on that.
Command.
Is there something?
So the
So
question.
the question was,
Yep, go
how
ahead,
can
Sean.
we access secrets? So
Answer any point CLI.
no.
And then there's another answer. What was that? Azure functions.
No. On the right track though.
Azure CLI. Well, close enough, eh?
Yeah, yeah.
So how could we access the secrets? That's a question.
So you can use service connections on Azure DevOps, or you can use service connections with access policies set up, and service connections just use a app registration inside of Azure AD, which uses a client ID and client secret.
No winner. So question number 3.
Oh, Rod was pretty close, wasn't he?
Okay.
How did we speed up development for Dev and QA?
Implementing unit tests, auto deploy, munit.
API order discovery. It was using the exclude pattern on the DevOps policy to so that we could manually go in and update the Dev and QA properties when we need to. So once we've set up secure properties, we can then go and adjust them and set them up inside the key vault as secrets, and then set up the tokenization inside of the properties file. But technically, I'd say, is it Sridhar Zavala. Auto deploy is kind of corrected now. That the
Okay,
speed up
cool.
development.
Yeah. I thought git push. Yep. Question number 4, Sean.
Question 4. How can we encrypt secrets for properties file? Yeah, so Shrita Zavala or Igor Brodowicz, is it?
So he's already a winner, so you gotta choose a different answer.
Okay, so Igor Brodowicz was the next one?
Mule encryption tool. All right. Cool. So yeah, so for those who won the quiz, just flick through your email address so I could send you the form, and yeah, you could get your free exam or training voucher. So yeah, so any more questions, guys? Yep, I think that's all, Sean. Thank you very much. I appreciate your yes to present this. And yeah, so yeah, I think we just have to, yeah. Last thing, guys, let's take a group photo. So let me just, yeah, if you could please turn on your video just for 1 minute. Oh, I think I should yes, set
Joy,
them all
yeah.
as a host. Should I set them all as a host to be able to do that?
I have never done that, so not sure if that would work or not, but give it a go.
Yeah, I don't think so. Well, let's figure out next time. So yeah, thanks everyone for joining, and I hope this session will help you to implement, the same or better implementation. So yeah, thank you so much and have a great night, guys. Thanks, Sean. Thanks,
Thanks,
Akana.
everyone.
Bye.
Thank you, Sean.
See you guys.
Sure. All right. See you guys
Thank
later.
you.
Bye-bye.